Good morning, mathematicians. My name is Brian, and today we're going to discuss a topic in mathematics called trigonometry. Trigonometry. It sounds like a very complicated topic, but you're gonna see that it is just a study of the ratios of sides of triangles. The trig part literally means triangle, and the metry part literally means measure. Triangle measure. And let's have an example right here. Let's say we have a right triangle, and when I say it's a right triangle, one of the angles here is 90 degrees. That right here is a right angle. A right angle, which is equal to 90 degrees. And let's say the height of this triangle is 3, and the base is 4, and the hypotenuse, when I say the hypotenuse, it is the side opposite the right angle, and it's the longest side of a right triangle. And let's say the hypotenuse is going to be 5. And let's verify that these sides work out, and we know from geometry that by the Pythagorean theorem states that the square of the sum of the measure of the sides of a right triangle is equal to the square of the longest side, the square of the hypotenuse. Right here, it's 3 squared plus 4 squared is equal to 5 squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, and 25 is basically 5 squared, which is the hypotenuse squared. When that out of the way, let's dive into trigonometry. Trigonometry has 3 fundamental functions: the sine, cosine, and tangent functions. We write sine, cosine, tangent. And this just says that for any angle found inside the triangle, we have special ratios, the ratios of certain sides. And let's say that angle in commonality in general is theta. We write sin theta, the cos theta, and the tan theta. This just reads as sine theta, cosine theta, and tangent theta. Now, to help us remember the definition of these specific functions, we write out a mnemonic. A mnemonic is something to remember the definitions by. And we write so, ka, toa. SOHCAHTOA. SOHCAHTOA means for any angle found inside the right triangle, we write sine of theta is equal to the opposite side over hypotenuse, and the cosine of theta is equal to the adjacent over hypotenuse, and the tangent theta is equal to the opposite side over adjacent. And this just tells us the definition of the sine, cosine, and tangent functions. And let's have an example, a numerical example. Let's say we consider this right triangle. Now, suppose that we consider this angle theta inside the right triangle. And we might ask, what is the sine of theta? What is the sine of theta? The sine of theta, based on the definition, is the opposite side over the hypotenuse. The side opposite the given angle is 3. It's across. It's the common sign to call it the opposite side. So therefore 3. And the hypotenuse is the longest side as defined to be 5. But the cosine of theta is just equal to the adjacent. What do we mean by adjacent? It is the side that forms this vertex that is not the hypotenuse. It is called with the included angle theta. Now, what is that? It's 4. So it's 4/5, which is the 5 is the hypotenuse, is the ka. Now, this is the tangent. The tangent theta is defined as TOA opposite over adjacent. So, the opposite is 3 and the adjacent is 4, so 3/4. Now, one might question, what about if we consider an angle here, alpha? Alpha. Now, we might ask, does that angle have its corresponding trig functions? Yes, of course. Now, what is the sine of alpha? The sine of alpha, as defined by this, is the opposite side over the hypotenuse. The side opposite angle alpha is 4. And notice that the side opposite alpha is the one adjacent to theta. So, by definition, opposite over hypotenuse, 4 over the hypotenuse, which is 5. Next, we have the cosine of alpha. The cosine definition is adjacent over hypotenuse. Notice that the adjacent side here is 3. And it is the opposite side of alpha. So, the cosine of alpha by definition is the adjacent 3 over the hypotenuse. And lastly, let's get the tangent. The tangent of alpha. The tangent of alpha by definition is the opposite over the adjacent. So, it's 4/3. And one might ask, notice that the sine of theta is the same as the cosine of alpha. And the cosine of theta is the same as the sine of alpha. And alas, the tangent of theta is the reciprocal, or the inverse, the reciprocal of the tangent of alpha. And in future videos, we're going to discuss the circular functions, the so-called unit circle, what does unit mean, and the trigonometric identities. So this right here are the basic fundamental examples of trigonometry. I haven't even discussed the 3 more functions called the secant, the cosecant, and the cotangent functions. And that will be discussed in future videos. Thank you.